Y'all help me keep an eye on time for what time it is, but it shouldn't take us. I got through these fairly quickly. I'm surprised y'all struggled this way with these three. Okay, the first one. Always read through it completely first. I've told you about that. Underline or whatever you need to do as you go through. So grass clippings are placed in a bin where they decompose. For time 0 to 30, the amount of grass clippings remaining in the bin is modeled by A, and you have this formula where A of T is measured in pounds and T is measured in days. And I'm not going to lie, whenever I first saw it, my chest was a little bit tight because it's like, oh my gosh, I'm going to have to take the derivative and the integral of this function with a variable in the exponent. And then I went, but wait, this is a calculator question. So there is little work that has to be done here. So let's read part A. Part A says find the average rate of change. And I underlined average rate. I went through and worked this just as if you would be working it to kind of help what I thought your thought process would go through. I underlined average rate of change because average rate of change and average value are two different things, and they at times will put those in and you get them mixed up. Remember, average value of a function is 1 over b minus a times the integral, but average rate of change is just slope, right? Okay. Find the average rate of change of a of t over the interval 0 to 30 and indicate the units of measure. If I need slope from 0 to 30, all I'm going to do is find a of 0. I need 2 points to find slope, so I find a of 0. Again, this is calculator problem, so I literally wrote a of 0 equals 6.687. I don't have to show any work for that. I use my calculator to do that. A of 30, I did write this one, but it's not really necessary. I'll look at the scoring. Yeah, look at y'all. 0.7829. And so then it says to find the average rate of change. So the average rate of change is, and I did set it up, 0.7829 minus 6.687 over 30 minus 0. And you get, and I did approximately. I'm always scared to put an equal sign because sometimes they'll say, well, it doesn't actually equal because it's rounded. And you don't want to lose your point. So negative 0.1968. Remember, units are very important. I go back and look. It's measured. T is measured in days, and A of T is pounds. So this would be pounds of clippings per day.
I got that right.
Okay, so let me find the scoring guide.
How about that? Yeah, I'm just recording.
This was 1 point. This was a part. This was 1 point for the answer with the units. Nothing else. 1 point. A rock. Yes. They would probably give that to you. All right. Part B. At least 3, yes. So they have negative 0.197. They went, yeah, 3 places. You would get credit for 197 or 196 is what the scoring guide says. Okay. Part B. Find the value. This is the one that I went, oh crap. Find the value of A prime of 15 using correct units. Interpret the meaning and context of the problem. And I went, oh my gosh, because A of T is 6.687.931 T. Let me just make sure I showed enough work on here. Yeah. Yes, and then I went, wait, it's a calculator problem. So I went to y equals, and I input 6.687.931 raised to the x, math 8. You put the function, so variables, y variables 1, with respect to x at the value 15. No, you show. So I literally said, and this is what the scoring guide says. The scoring guide says a prime of 15 equals negative 0.164 or negative 0.165. You get a point for just that. This, right? You get a point for that. That's why I said don't skip the first one. Yes. It is. Now, the other part of the question said using the correct. What's different about it? Yeah, plugging in y equals, it makes it easier too. Yes, so that's your other 1 point because this was 2 points. So it says find a prime. So the derivative is going to be your rate, right? So this is pounds per day. No, because it's not the derivative of the derivative. Remember, this is finding the same thing. They're just different approximations. Yeah. That is exactly right. You have to say on day 15, because this is the derivative at 15. On day 15, the grass clippings are decomposing at a rate of 0.164 pounds per day. That was your second point. That was 2 points. Okay. So far we're 3 points in, but these two, part A and part B, should have taken you maybe 3 minutes. I mean, they were. All right, part C. I want to make sure I get it through everything, so I need to keep rolling. Find the time for which the amount of grass clippings in the bin is equal to the average amount. Okay, so here's my average function. And I promise y'all, I underlined in part A and wrote above it not average value, and didn't even read ahead to part C to know that part C is asking for average value. When you see how easy part C is, how do you find the average value of a function? Write this down somewhere where you can times the integral from A to B of whatever your function is. We did that, yeah. It is on the sheet. It should be, yeah. The no code, yeah. We have, but it's been a long time. We did it back when we did A-Rock and all. We spent more time on A-Rock, but average value shows up all the time. Do what? Oh, no, we didn't then, did we? First intervals, I mean. Okay. I remember doing it. I don't remember where we did it. Okay, but average value, so 1 over b minus a, again, this is a calculator problem. So all I have to do is say 1 over, I did a little more than I had to. 1 over 30 minus 0 times the integral from 0 to 30 of, and then I put the function here. But again, I did this on my calculator. This equation was still plugged in my y equals. Yep. I showed this. I always show my setup because sometimes you get a point for the setup. Yeah. You see one up there? If not, open the middle desk drawer and get one. It'll have to be sharpened. So I went in and I said, okay, 1 over 30 times. This time it's integral, right? Time the integral. I went in y variables with respect to x from 0 to 30. No, wait, that's not right. That's not right. That's not right. I got it on here. What? Say that again. The answer to C is 12.415 days.
We're looking for detail. I got about 36. Well, it was like, I could, okay. Oh, yeah, look, so I was going to, I set it equal to.
What did I do?
So I plugged it, I just kept on plugging in and it plugged from.
6.687. 35.054. I'll show you. No. Okay. Come on. Gotta take this at least out to 30 if I want to find the integral. I'm finding the integral from 0 to 30. Because I got the calculator, somebody's got the calculator I used. No? Okay.
Whoa.
Well, and then you have to multiply by 1 over 30.
How do you get it to shade like that?
Wait,
I
what's
can
the
never get it
value?
to shade like
Is it
that.
80?
Yeah, divide by 1 over 30.
Is the value 80? When you divide that by 1 over 30,
Okay, so you divide by 30, but here's the thing. Right. So what does that mean? That's saying 2.75 is the average value of the function. That's the average weight. When does that happen? So now I have to take it and say, okay, this is approximately 2.753. When does, what's my function? When does 6.687 times 0.931 to the t equal 2.753? That will happen at approximately 12.14. No, 12 point. What do you mean? Okay, so so I would move this over here, make it equal 0, and then graph it and find where it crosses the x-axis. You got a calculator. So 6, yeah.
Okay, so like on D, when I got to that part.
So I got here, and then I said minus, what did I say it was? That's the average value of the function. So when does it equal that? And then you calculate the 0. All right, I want to make sure I got enough time for everything, so I got to keep moving. But 12.418, 12.415, somewhere around there, that's your days. Okay. So back to algebra skills here. How do we solve an equation like that? Graph it. You could graph this and find where they intersect, calculate the intersection. Or you can do what we did, make it equal 0, find the 0. Any of those would work. So that was 2 points. 1 point you got just for the setup, knowing what the average value of the function meant. So if you wrote that, you got a point. And then if you got the actual answer of 12.415, you got a point. All right, last one, part D. It says when t is bigger than 30, so when I pass 30 days, the linear approximation to a at t equals 30 is a better model for the amount of grass clippings remaining in the bin. Use L of t to predict the time at which there will be 5. So there's several things going on here, right? The first thing I notice is the linear approximation, and anytime I see linear approximation, I think tan line. Okay, that's what linear approximation means. If you ever see that, no, that means tan line. So first thing I did on this was I said, well, okay, I need the slope at 30. Again, this is a calculator problem. So in deriv, when it's 30, you will get approximately negative 0.055. I took it all the way out because I'm extra. And then I said, well, to write the equation of the tan line, I need a point and a slope. So I found a of 30, again, on my calculator, and I got 0.7829. And so y minus 0.78. I wrote it in slope-intercept form first. I mean point-slope form. But then I went back and rewrote in terms of the variables that they asked me to use, and I solved it for L of t. They told me to find L of t. So L of t equals negative 0.0. Well, you don't have to take this out as far as I did because again I'm extra. I found the equation of the tan line. It asked me for linear approximation at 30. That is the equation of the tan line.
I took the equation and literally set it at 0.5. I was only one number off.
So you do set the equation of 0.5, but it's the equation of the tan line to 0.5, not the original equation. No, because this has got to be the tan line. It's the equation of the derivative at that point, at that particular point. So okay, so 2 points for L of t.
Okay,
I just got a little.
All right, so when we find the equation of a tan line, we find the slope, which is the derivative at that point, and then we need a point. We need a point and a slope to write a line. The point uses the original equation. The slope uses the derivative. So then I just plugged in point slope form. So that's 2 points. This was a 4-point part. Part C was a 4-point part. 2 points for L of t. Then it says, use L of t to predict the time at which there will be half a pound of grass remaining. I need time. When will this equal 1/2? If you knew to take L of t and set it equal to 0.5, you got a point. Even if your L of t was wrong, if you set your L of t equal to 0.5, you got a point. It just defined it. All it did was it told you, it said, use L of t. L of t is the linear approximation to A at t equals. You see linear approximation, tan line, every time. Yep, the equation. No, it'd have to be a new equation, the L of t. All right, and then the answer itself, which of course is a calculator problem, so you don't even have to show any work for this. I put on my calculator 0.5 minus 0.7829 divided by negative plus 30, and I got 35.054. All right. We just spent 15 minutes explaining that one, which is the time that I gave you to actually do it. So I think that was a pretty reasonable time frame. Let's go on to number 2. We only have 25 minutes left, so we got to move a little bit faster. All right, let region R be the region enclosed by the graph. Bleh. It's a nasty polynomial, but I'm not going to have to do much more with it other than just putting it in my calculator. And the horizontal line y equals 4. I'll show you. Shown in the figure above. Find the volume. So let me draw this because I have little notes written on. So you have to find the intersection point on your calculator.
I'm talking about the other.
2.138. Oh, you're saying no. Why are you saying? I'm the answer. That's my answer.
What was that other intersection? 0. I tried, no, because I put it, gave you like, yeah, and it can't like change.
That's 0. That's always 0. You always read that as 0.
graph looks like. I gotta see that.
First thing I did was find the intersection point, so I know that this is x equals 2.3, and actually that's, I'm gonna just write this point. Again, if it's a calculator problem, that's because you are supposed to heavily rely on your calculator. Do not do it on your own. Chances are it's not even a problem you're going to know how to do on your own. All right, so part A says find the volume of the solid when it's rotated about the line y equals -2. Okay, so I've got to find hole and hole. Radius of the whole thing. Now I'm rotating about this green line. So I have to go from here all the way down. It's just 6. The whole thing is 6. The whole. No, probably not. I don't know.
What's this hole?
The radius of the hole. Now look at what the hole goes from. Bless you. So this plus this. That's exactly right. So it's.
Why can't it be 6 minus x to the 4?
No. It's plus 2. Don't think about where this is. Think about.
I don't understand. I thought you were the whole thing minus, but when I'm thinking of the whole, I'm thinking
Here,
of
let me
like,
shade
like
this.
this whole thing minus this. I'm thinking the way Aaliyah is. So I did the whole thing, this whole
All right,
thing.
you did the whole
minus
thing
this.
6 minus that.
Minus.
That's if you're rotating about the x-axis. Yes, if you rotate about the x-axis, then this is your whole. But you're rotating about this line, so all of this is your whole. So this whole thing is rotating about that line on the bottom. Yeah, it probably will.
So, the -2 is a whole, but it's conceptually just not
Right, because you're talking about a length of distance there.
That is the whole, like that. How did that fit? Well, that part is the whole.
Right. So now the area of the hole, pi r squared, so I've got 36 pi. Area of the little hole, okay. Don't listen, you will do very little computational work on calculator problems. If y'all get to where you're doing a lot of computation and it's a calculator problem, you're probably off on the wrong track. Okay. If you are doing lots of computations like multiplying, dividing, adding, subtracting, lots of stuff like that, you're probably off in left field somewhere. The calculator problems are dependent on the calculator. All right, so how do we do this? So the question asks for the volume when rotated about that line. So the volume is, remember the pi goes on the outside. I already found the intersection. I'm going from 0 to 2.3. 36 minus x to the 4th minus 2.3x cubed plus 6 squared dx, and I put it straight in my calculator exactly like that to get approximately 98.868. This problem was worth 4 points. 4 points. You got 2 points for just setting up the integral. If you got this, you got 2 points. And listen, what they would have taken also, I was a little surprised by this. What you could have gotten you credit was 4 plus 2 squared minus f of x plus 2 squared. You could use the f of x instead of writing what f of x was in all this, and that would have saved you an immense amount of time. But yes, all right. You got 4 points right. 2 points for the integrand. You got a point if you just got the limits right. If you knew it went from 0 to 2.3, you got a point. And then you got 1 point for the answer. That was a massive question. Okay, but look at the amount. I don't have a lot of work on here. You had to understand how to rotate about a line that was not the axis. That was the whole point of the question. Part B. Part B says region R is the base of a solid cross sections perpendicular to the x-axis are the base of an isosceles triangle.
So I can't even put this in the calculator.
What?
I can't put it in the calculator.
Okay, let me show you. All right, so y equals, is this the right equation? Yes. Okay, so all I did whenever I did it, Noah, I went math, integral, y variable, y1 with respect to x, and I need to take it from 0 to 2.3. And remember, you got that pi outside of it, so I had to say times pi. Oh, I didn't do, wait. No, I didn't. It's, your equation is actually going to be 36 minus all of this squared. Yep. Yeah. That's what I got. 36 minus x to the fourth minus 2.3x.
I thought it was plus 4.
I combined those two. So then all I did was second function interval or integral from of y1 with respect to x from 0 to 2.3, and I got, bless you, and now times, of course, my pi that sits out. 98.8. I didn't. We're doing A. We went back to A. He didn't have to do A. Okay, so for part B, that gives you the leg of the triangle. So this yellow piece is the leg of the triangle. The hardest part about cross sections, find the area and then integrate the area. That's what you have to remember. So how do I find the area that is not a right triangle? How do I find the area of a right isosceles triangle? 1/2, but they're the same, right? So it's whatever that leg is squared, because the leg and the two legs are the base and height. So if I can find this and square it, I can find the area. So what is the yellow length there? That's exactly 4 minus, and I'm just going to write f of x. And that's acceptable. That is okay. 4 minus f of x there. So the area of one triangle, 1/2, 4 minus f of x squared. Is this part, what part is this? This is part B. You get a point for the integrand and then a point for the answer. Oh no, this is 3 points. You get 2 points for the integrand, 1 point for the answer. All right, so now I integrate 0 to 2.3. This one does not have a pi on it because I'm not doing circles, right? I'm just doing the area of, so I've got 1/2. I put the 1/2 on the outside. It doesn't matter where you put it. 4 minus f of x squared dx. There's 2 points right there for that. 2 points for this. And then the answer, 3.574. 1 point. That's a 3 point, yeah. The last one was the easiest, and had you just thought about it, you would have seen that it really wasn't that bad. The vertical line x equals k, so I went up to the top of mine. I mean, I drew all over mine up here. I put the line x equals k, and I just randomly put it somewhere. Okay, so I'll let that be x equals k. It doesn't matter where it is, it's a conceptual value, right? It divides region R into two different parts, and it says the vertical line with equal areas. So now I've got to get off of volume and think areas, right? Top minus bottom curve? Or right. Okay, so write but do not solve an equation involving an integral expression whose solution gives the value of k. Well, okay, but think about it. This area, so give me an expression that would give me the area from here to here. From 0 to k of what? But there's two curves there. How do you find the area between two curves? 4 minus f of x equals k to 2.3, 4 minus f of x.
Plus 4.
2 points. Okay, so you got 1 point for the area of one region and 1 point for the equation. What I flip around? Top curve minus bottom curve. Right. I went from here to here, and then I went from here to here because it said those areas should be equal. I didn't have to solve it. I didn't have to figure out what k was. All I had to do was set it up. Number 3, y'all said was the easiest. I thought it was the hardest. It's okay. It's okay. All right, no calculator. I find that it's a little bit harder. I told you. All right. I'm not going to draw it exactly, but this is the graph of f. We've done a couple FRQs with something like this. So the function f is defined on the closed interval, -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. Let g be the function defined by, and here where this is key, g of x equals the integral from -3 to x of f of t dt. Okay, so this is the graph of f, but it's also the graph of what? The derivative of g. Okay, so you have to understand somewhere. I bet you get a point somewhere for writing that, but I don't know. But huh? Well, if g of x equals this, the opposite of the integral is the derivative. Do what? Yes, yes, yes. So the first one asked me to find g of 3. Literally take what they give you and put a 3 in there for x. Well, we have the graph, right? And if I go from -3 to 3, it goes to here. I've got, or it goes actually a little past, I think. Yeah. You've got the area of 3 triangles here.
I'm pretty sure -3 is like.
Oh, -3 is right here?
Yeah, I got that.
Yeah. So I've got 2 triangles then.
What's the answer?
9. The answer is 9. The area of this triangle is, let me see, this is my work. I'll just write what. 1/2 4 times 5 minus 1/2 1 times 2. And you get 9. I know I messed up. It's this triangle and this triangle. That one was only 1 point. And that was for the answer. Because there's just areas of the triangles. There's just 1 point. Part B, I felt like was the hardest one on the question. From -5 to -3 and 0 to 2. I set up. Did you really? Did you do sign analysis for both of them?
I said when x is greater than -3.
Here's what I did. Now, when you have these, here's what you have to remember on part B. You have to understand that the derivative is equal to the function.
You have to understand on what.
That's right. Okay, so I'm looking for increasing and concave down. My first derivative is going to give me increasing, decreasing. My second derivative is going to give me concavity, okay? So if I've got the graph of the derivative, okay, where the derivative is positive, the function's increasing, negative is decreasing, so I need to look at zeros of the function. I'm going to put my endpoints on here. I go from, what is it, -5 to 4. Keep these lined up because it will help you. No, you did not have to do this. This is what helps me see it. All right, so now I look at my graph. Where am I hitting 0 on these points, right? So for this one, I put -3 and 2. Okay, so I'm positive, positive, and negative, which means I'm increasing, increasing, and decreasing. Now, concavity. Concavity is going to change. I don't have the original function, so I'm looking at maxes and mins of the function, right? So again, -3 is one of my points, but also 0. 2 is no longer a factor in concavity. So if I want to know the sign of the second derivative, I can look at the slope of the first derivative. What is the slope from -5 to -3? Look at your picture. Negative, so it's concave down. How about from -3 to 0? Positive, so it's concave up, and negative, so it's concave down. So I need all the intervals where it is. -5 to 3 is the easy one, and then it's from 0, but it switches at 2 also.
Why doesn't he play?
This is what I did. I said, what did I write? I said, is positive and decreasing because, I said because it's positive, because the derivative is positive and decreasing on those intervals. So that one was, what letter was that, B? 1 point for the answer, 1 point for the reasoning. All right, part C. Part C is 3 points. It defines h of x for you. I felt like part C was more of an algebra question than it was, well, I guess you had to know how to, yes, you were. You absolutely were. So the derivative of h, derivative of the top, times the bottom, minus the top, times derivative of the bottom, all over the bottom squared. And then it said to find h prime of 3. So I literally just went through and put 3's in everywhere. G prime of 3 times 15 minus G of 3 times 5, all over 9 times 25,
Oh, no, I did
225.
I did swear it. No.
You've already found that in part A. Part A said, what is G of 3?
Oh, you know, I would have
You found it.
anyway if I got
Derivative at 3, I'm looking at the slope, right? But because that what was graphed is the derivative, really, I'm just looking at when x is 3 on my graph, what is y? 225.
Probably, I would.
25 times 9. Bottom squared. 5x squared. So you got to square that 5 also.
I didn't like square it at all.
Part A, I got 9 times 5 all over 225. If you're Dylan, you left it right there and you didn't do anything else with it. If you're Stacy McGee, you went through and simplified and did everything you could by hand to get down to negative 1/3.
No, I got 2/3.
2 points for, you got 2 points for this, for using the quotient rule and setting it up. With X in it, 1 point for the answer. Okay, it needs to be right. Very last one, which is D, it's worth 3 points. The function P is defined by, this is a heavily tested derivative. P of X, it is X squared minus X. It says find the slope of the line tangent to the graph of P where X equals -1. All you're finding is the slope. All I need is P prime of -1. That's it. Wait, I got 6. It's 6. Yeah.
What?
All right. Well, let's see why. Derivative of F. All right. You got a point for finding the derivative. Okay. So if you said this is derivative of F times 2x minus 1, because of the chain rule. The chain rule, derivative of the outside times derivative of the inside. You got a point for that. Then if you plugged it in, the derivative of F, -1 squared is 1, minus -1 times -2 minus 1. So I've got the derivative at -2 times -3. F prime of -2, that's negative. Oh, yeah, sorry. So what's the slope of the tan line at 2? You've got the graph, it's -2. But you didn't chain rule it. You got to multiply by -3. There you go. 2 points for this part, 1 point for that part. So, looking at the first 3, and these came straight off. This was the 2014 exam.
I could have done so much better.
You said the slope
I got 7 points on the